So when we're looking at this, I want to do the speaker view. So why won't it show? My screen. Okay, well, here we go. All right, so looking at number 1, it says identify the domain. Remember that domain is the X values, okay? The range is the Y values. You want to determine if it is a function. For it to be a function, that means the X's do not repeat. The X's do not repeat. So if I'm looking at number 1, I go through and I look at all of the X's. Oops, what I notice is the -5s repeat. So therefore, I know right away that this is not a function. So for the function question, it is a no. Now, when I'm listing the domain, and remember, that's my X values, we do the curvy brackets and we put it in order from least to greatest. So first one, the smallest one is -5, but notice it is written twice. I only write it once. So we have -5, then -2, then 3, and we close curvy brackets. Now we're talking about the range, which is the Y values. And again, it is in order from least to greatest. Curvy bracket. And I'm going through and I'm looking. Okay, so this is going to be -2, comma, -1, comma, 0, comma. It makes much better sense if you do the right numbers, Miss Wilson, and not mix up the X and the Y's. Here we go. Let's try this again. So I'm looking at, it's going to go -1, comma, 0, comma, 6, comma, 7. There we go. Now that's the correct range, which is very common to go through and mix them up. So double check like I did. You're doing the same thing for numbers 1, 2, 3, 4, 5, 6. For 4, 5, 6, a hint, write as ordered pairs first. This is what I might do as we go through this, because I can't work the whole thing. I'm going to work 1 or 2 from each section. Okay, there's Ariel. Okay, hold up just a second, guys. I'm going to go ahead and work number 2 while I run to this breakout room to help out real fast.
You're muted, Miss Wilson.
Thank you. Yes, you can use your notes and a calculator. Okay, on everything that you're doing and the test as well. And notes means you can use your big binder. So make sure that you take good notes. All right, number 7. You're given the domain. Remember, that's X. Okay, just making sure I was answering any questions. Okay, so, and I want to find the range. Remember, that's the Y. So I'm going to take each X value and I'm going to plug it in. So I'm going to work this 3 times. So I'm going to have Y equals 5 times -4 plus 11, which gives me -20 plus 11, which gives me Y equals -9. And yes, you have to show the middle step. So now we work it with plugging in -1. So I have Y equals 5 times -1 plus 11, -5 plus 11, Y equals 6. Then we take the last, which is 0, and we have Y equals 5 times 0 plus 11. So that's 0 plus 11. Y equals 11. So we have that our range curvy bracket is equal to, and we put it in order from least to greatest, -9, comma 6, comma 11, curvy bracket. Okay. For number 8, 9, 10, you're doing the same thing. For 9 and 10, you are only adding that now you write these as ordered pairs and you plot them. So for instance, if I were looking at this number 7 and I needed to write it as an ordered pair, this would be -4, comma -9 as the ordered pair. -1, comma 6. 0, comma 11, and then I would plot these 3 ordered pairs on the graph. That's the only added step for 9 and 10. Okay, moving right along. So that takes care of 7 through 12, because those are all the same type of problem. All right. Number 13, where this is where we're talking about the 4 different types of slope. Okay, we have positive, which goes uphill. We have negative, which goes downhill. We have, you might remember, it's horizontal. And remember, slope is rise over run. So if it's horizontal, that means I'm not going up or down. I'm not rising. I'm just running. I'm going over and over up each other. So that means 0 divided by a number is going to equal 0. So this slope, horizontal, is considered to be 0. And then last, we have the vertical, which means based on rise over run, yep, I'm going up all day long. I'm not running. I'm not going left or right at all. So the 0 is in the bottom. Anytime the 0 is in the denominator, it is called undefined. So now you look at your graphs and you determine it. So if I look at number 14, we're figuring out rise over run. So I'm going to figure out how much do I rise to go from this point to this point. 1, 2, 3, 4, 5, 6. So I'm rising 6. And I'm running 1, 2. So this is 6 over 2. This is not my slope because you have to simplify. 6 over 2 simplifies to 3. So therefore my slope is 3. And you show the curves, the units as you're counting as your work. All right. Next, we have the slope formula. You're going to do all of the study guide except for 26 through 37. And the purpose is because you haven't done much of this work or practice in a long time. Okay, and I'm doing some of it with you. Okay, so for slope, it's y2 minus y1 over x sub 2 minus x sub 1. This is my slope formula that you get to use. So let's work one. We're going to work number 18. Okay, well, as you read, this is the first point. So therefore, this is going to be x sub 1, y sub 1. This is the second point. So this is x sub 2, y sub 2. And now I plug into my formula. You'll notice and maybe remember me shortening this to the change in y over the change in x. And guys, if I'm going fast and you get stumped, listen, I'm going to put the video in Edpuzzle or share it with you so that you can watch this video and go over and over with it, okay? All right, so we have to find our slope. It's the change in y over the change in x. So I've got to do my y value. So I'm going to have 9 minus 4 over -3 minus -2. It's not -3 minus 2. It's -3 minus -2, which means the double negative becomes a big plus. So we now have 9 minus 4 is 5 over -3 plus 2 is -1. And that simplifies to -5 as my slope. You work the same process, excuse me, for the next 3 questions. Okay, next section. This is where we pull in application. Rate of change is the exact same as slope, except you now have units. Slope, but it's with units because it's a word problem. Okay, so it says to find the rate of change from February 1st to February 7th. So that means I'm looking at these 2 sets of points right here. This is my first point. This is my second point. Now I've got to think, well, which one's X and which one's Y? Well, my balance depends on my date. So remember, blank depends on blank, and it's always Y depends on X. So we have that the money depends on the date. So therefore, this is X and this is Y. So now I know how to set up my slope to find. So we're going to do the change in Y over the change in X. Get out of this place. 39, okay. All right, so we're going to have 872 minus 443 all over 7 minus 1. And this is where the handy dandy calculator comes into play. And we have 872 minus 443, enter, and that gives me 429 over 6. So now I'm going to divide by 6, and we get 71.5. But remember, this is rate of change. That means I've got to do units. This means it's $71.50 per day. When it says rate of change, you have to have units. Okay, you have to have the units. The only difference between B is you're choosing different points. You're using the 7 and the 15 point. Otherwise, you work it the same. Okay, moving on. If I'm looking at 23, it is 23 through 20, all of 23. It's the same thing, except I'm pulling my information from the graph. Instead of it giving me a table of values, I'm now looking at it from a graph. So if I am looking at, for instance, B, it says to find the rate of change from 24 to 32. That means I'm going from here to here on my graph. So I can think of this as rise over run. Well, my rise, I'm not going up or down at all. So that's 0 over how much am I running? Well, to go from 25 to 32. So therefore, I'm technically doing 32 minus 24, which is 8. So I have 0 over 8, which actually equals 0. So now I'm going to, I still have to have units because it's a rate of change. Okay, please try to stay on camera. Okay. All right. So some of you should be back on camera with this. Okay. So we've got units we have to do. Well, it's weeks on the x-axis, grade, so points on the y-axis. So this is 0 points per week for this section of the graph. Okay, so now if I'm looking at 24 real quick, in here I'm given 2 points because it says 2 hours into the trip she had 15 gallons. Well, again, we've got to determine what's X and what's Y. Then 15 gallons, she had 15 gallons of gas in her tank. And 7 hours into her trip, okay, that was 2 hours and 15, and 7 and 3 gallons of gas in her tank. So therefore, the amount of gallons depends on, so we would have gallons depends on hours. Normally time is your X. So therefore this is Y, this is X. So therefore I can have the points 2, 15 and 7, 3. Once I'm given 2 points, I can use my formula. All right, moving along, because that was taking quite a bit of time. I've got to get to more parts of this. Okay, slope-intercept form. We're going to write down the equations, but you are not doing 26 through 37. But you do need to remember the equation form. So we have y equals, slope-intercept is mx plus b. Remember that the m is the slope, the b is the y-intercept, which is where it crosses the y-axis. This is the b. Standard form is ax plus by equals c. What you have to make sure you understand is you've got to remember solving to go from this form to this form, which we're about to practice some. Okay, next page, flipping this over. So if I'm looking at, real quick, we will do 38. Remember, this is understood to be a -1. Okay, let's look at, I'm going to look at 42 because I'm going to encompass everything together in that problem. Okay, so with this, your first step is we have to get it into the form of y equals mx plus b, which means I need to solve this to get the y by itself. So I'm going to move the 4x first to this other side of the equal sign. So I'm going to subtract 4x from both sides. We bring this down and I have negative, don't forget that that's a negative, -3y equals -4x. I'm writing the 4x first because it's an mx plus b form. So it's a -4x minus 21. Now, next step, because y is not by itself yet, I divide everything by -3. And we get y equals 4/3 x plus 7. Now that it's in slope-intercept form, I can pull out what my slope is, which is 4/3, which means since it's positive, I'm going to go up 4 to the right 3, or I'm going to go down 4 and to the left 3. And I also pull out that my b is 7, and b is the beginning. This is what you start with. So we start here. So I start at 7. 2, 4, 6, 7. So I plot that point, and then from there, well, I can't go up. So that means I have to use this option. So I'm going to go down 3, 1, 2, 3, 4, go down 4, and then to the left 3. So 1, 2, 3. And I'm going to continue that all the way through. So therefore my graph is accurate. And then we use a straight edge. And we draw a straight line. We play connect the dots. And yes, you use a ruler. This has encompassed everything you need for the sections for 38 through 45. Again, if you need to rewatch, pause, rewatch to watch the steps again to apply. Keep going. I'm actually going to talk about 44 real quick. Okay, with 44, you'll notice there is no x in equation. So never crosses x-axis. So I've got y equals 6. So I know it's going to have to be at the 6 on the y. But if it's never going to cross the x-axis, then that has to be a horizontal line for it to never intersect. Because it's got to be parallel to the x-axis for it to never intersect. You apply the same thing to 45, but just in reverse. And you can check your answers in Schoology when you're working these as well. The answer key for everything is there. Okay, so for the next part, this is where you have to write it in slope-intercept form. That means you need to find what the M is and what the B is from the graph. So the first thing I always look for is, I'll write down the M, and the B is the B. I always start with that. So that's right here. So that's at -3. Now I figure out my slope. 1, 2, 3. So I'm rising 3 over 1, 2, 3, running 3. You always simplify. This equals 1. So my equation is y equals 1x minus 3. Technically, you don't have to write the 1. You could just write y equals x minus 3. Okay. Moving right along. So I want to make sure we can get through everything, and then I can go back and answer some questions if you've got them. Okay. Slope-intercept form application. This is where we have to pull out the information from the word problem. Remember, rate of change is the same as the slope. Initial value is the y-intercept, or the B. Rate of change is your slope. Okay, so Bryn has $12,000 in her savings account and plans to save an additional $350 each month. That word each tells me that's happening over and over and over again, which means that's the rate of change. So there's my slope. My rate of change is $350 per month. In order to purchase a car, write an equation. So I'm looking for an equation to represent the total amount she has saved each month. Identify your variables. That right there means that I'm saying let x equal y equal. That is what this means. Okay, so the initial value, that's what I start with. Well, I start with $1,200 in the savings account. Okay, well, if $1,200 is representing the y-intercept, that would mean, okay, that the y is probably the cost. But the way that you figure this out is, remember, you do blank depends on blank. Y depends on x. So therefore, the money depends on the number of months. So therefore, what is the independent, which is x? That is the number of months. The dependent is y, which is the cost, which is your money. Or it's actually not cost, sorry, it's savings. A lot of times it's cost. But in this word problem, it's how much you save. It's the savings that you earn. So my equation is got to be in the form of y equals mx plus b. So I just take in my information and plug it in. So I have y equals 350x plus 1,200. There's my equation. This is the type of work that you need to finish this out. All right. For 49 and 50, it's the same thing that we just did up here. All you're adding is if it said, okay, what is the cost? So I'm going to add a little bit to this problem right here, okay? We want to know for this type of problem, how many months? So I'm going to write up here. How many months for a savings of $2,950? How many months for 2,950 savings? Well, this means the 295 is the money, which is the y. I want to know how many months, which is my x. So therefore, I can take this 295 and plug it in for this y. So I would have 2,950 equals 350x plus 1,200. And now we solve that equation. So I subtract 1,200, and yes, you should be doing all of this right now with me, because we're just solving the equation. So I have 1750 equals 350x. Now this is connected by multiplication, so I divide by 350 on both sides. And we get that x equals 5. So that means it takes 5 months to get to this amount. Okay, a little bit left. We're talking about direct variation. That's the last section. When we're dealing with direct variation, things you need to remember. Direct variation is a proportional relationship. Okay, in which there is a constant rate of change between the variables. That is k equals y over x. And the y-intercept is always 0. So that means the graph always goes through the origin. Okay? Graph through origin, which is the 0, 0 on the graph. Okay? Your equation for a direct variation equation, it is y equals kx. It's got to be in that form. Okay, so we're looking, it says to determine if it's a direct variation. If yes, identify the constant of variation, which is the k, constant for k. And then we have to write the equation, which is in the form of y equals kx. All right, so in order to figure this out, to find the k, we do y over x. So that means I'm doing 9 over -3. That equals -3. Well, 0, 0, that's what it's supposed to go through for a direct variation. Okay, so we've got to prove the rest of them. So I'm going to do -6 over 2, which is -3. -12 over 4, which they all equal -3. So since these are the same, it is direct variation. It is a direct variation. Let's write that. Okay. Is a direct variation. So we would write the word yes. And now that means I need to label what is k. These are all the same. This is what my k is right here. So k equals -3. In order to write the equation, we take the k and we plug it in. So my equation is going to be y equals -3x. There's 3 parts to this, whether it's a direct variation, what the k is, and what the equation is. And you're doing the rest of these the same way. Okay, that's going through everything that's on the note. Take that back. Okay, looking over here, you're looking to determine if it's a direct variation or not. Okay, looking on the back. If any, add or subtract, not a direct variation. Okay, when in y equals kx form. Okay, if there's any addition or subtraction in the equation, once it's in the form of y equals, like you saw for y, if there's addition or subtraction, it is not a direct variation. Okay. When we're looking at the equations, the graphs. Well, if it wants to know if it's a direct variation. 61, it doesn't go through the origin. So this is a no. Right off. I can tell right off it is a no. This one goes through the origin. So to find the direct variation, remember that the constant of variation, that's just the special name for slope in direct variation problems. It is the same as the slope. So that means I need to find the slope for 62. Okay, 64. This is where we're pulling in the word problems. The amount of interest earned on a savings account varies directly. keywords. That means this is a direct variation, which means my equation is going to look like y equals kx. I need to find what the k equals. So we have, if 34 is earned on a balance of $850. So is earned on a balance. Identify the constant of variation and write an equation. Well, it says the interest varies directly. So it's always y varies directly with x. So whatever is in the y spot, whatever comes first. So therefore, this is going to be the interest with the savings. Remember, k is found y over x. So that means I'm going to do the amount of interest, which is earned. Earned means it's interest. So I'm going to have 34 over 850. So I'm going to, in the calculator, do 34 divided by 850, which gives me that k equals 0.04. So my equation is going to be y equals 0.04. Oh, this is a rate of change. So this is 4 cents per dollar, because you have to write the units. So there's part of it. And here's my equation. The only thing different with 66 and 67 is where you're having to, once you've done this, you plug in some information into the equation. Okay, that's gone through everything. Let me stop the recording.